Hello students. We were seeing the dynamic programming. In the last class, we have seen the Floyd's algorithm. So, sorry, the Warshall's algorithm, where it is used for finding the transitive closure. Now at this stage, we will go for the next algorithm, that is the Floyd's algorithm. So when you talk about the Floyd's algorithm, we are going to find out the all pair shortest path problem. So what is this all pair shortest path problem we have to see? So here we are going to see with the help of the same procedure which we have used in the Warshall's algorithm by using the dynamic programming concept. So when you say it as the dynamic programming concept, we have seen that we will be using a recurrence relation. A recurrence relation, we will be having an initial condition. Based on the initial condition, we will be setting the values. So each stage we will be finding out the values, and we will be getting to know what will be the best one. So here it's used to find the distances. So here we are using the same procedure of Warshall. Only thing is there we have used the Boolean matrix. Here we will be using it as a as some values. Okay, so we have seen in the Warshall's algorithm that whenever you go for a particular problem, here in the initial stage, the first stage, we will be taking all the direct values. But as and when you proceed further, each vertex will be considered as the intermediate vertices, and we will be calculating it. So here we are going to find the length of the shortest path from each vertex to all other vertices. So here it will be recording the length of the shortest path in a n by n matrix, where it is nothing but it is called as the distance matrix. So when you say it as the distance matrix, we will be taking a graph where the graph is a directed graph and it is a weighted graph. So the element in the ith row and jth column of the matrix will be indicating the length of the shortest path from vertex I to j. So when you say it as Floyd's algorithm is applicable for both the directed as well as undirected graphs. But it should be a weighted graph, provided they should not consider they should not have a negative length. Why? Because see, whenever you find the all pair shortest path problem, shortest indicates it is a minimum value. If you have a negative value, always you will be ending up with a negative value. So here we are going to see the Floyd's algorithm by computing the distance matrix of a weighted graph with the n vertices through a series of n by n matrices. Okay, where you will be saying it as D0, D1, D2, etc. up to Dn. So D0 will be your initial matrix which will not consist of any intermediate vertices. Whereas Dn is the last stage where you will be considering all the n vertices as the intermediate. So when you say it as Dij of k is the shortest path from Vi to Vj, with their intermediate vertices not numbered higher than k, then dk is obtained from its immediate predecessor dk minus 1. So you will start with Vi, you will be ending up with Vj, a list of intermediate vertex which is not numbered higher than k will be given. Now, when you partition Floyd's algorithm, we can partition the path into two disjoint subsets. Those that do not use the kth vertex as the intermediate and those that do. So the paths of the first subset have their intermediate vertices numbered not higher than k minus 1. The shortest of them is Dij of k minus 1. So the length of the shortest path in the second subset, if the graph does not contain a cycle, negative length, the subset use the vertex vk as intermediate vertex exactly once. So what do you mean by it? So here we are having D0, the next stage is D1. So to construct D1, we are depending upon D0 and vertex 1 will be taken as the intermediate vertex. Similarly, in DK, this is the kth stage. In kth stage, it will be depending upon K minus 1 and K acts as the intermediate vertex. So like that, each and every subset will be consisting of two subsets. One is the path will be consisting of two subsets. The path will be considering with the intermediate and the without, that is your direct vertices itself. So the path Vi to Vk which has been given, we will be directly finding the value Ij of K minus 1. But if you want to find out the path with the intermediate, add the two values. That is, if suppose if you want to find out a path from A to C, B acts as an intermediate vertex, then A to B plus B to C of the previous matrix. And you know, initially you in a recurrence relation, we need to have an initial condition, and the initial condition is the weighted matrix directly from the graph. So here also in the Floyd's algorithm, we are using a algorithm with the three stages or three steps, where for I k equal to 1 to n, I equal to 1 to n, j equal to 1 to n, dk of ij. Dk of ij is, since we are going to find out the shortest, minimum of dk minus 1 ij, comma dk minus 1 ik plus kj. So now when you finish all the three loops, you will be returning with the dn. So again, here it's a summation formula. So we will be using the, and there is only one single operation. So we will be finding using the upper bound, lower bound formula, and we will be getting to know what is the value of I equal to 1 to n, which will be 1, which will be n times, n times, n times. So this operation is going to be performed n into n into n, which will be of the time taken will be n cube. Understood? So now you are given with a graph, you need to find out the time complexity. So how to find out the time complexity? So to find out the time complexity, what you are doing is, we go with the Floyd's algorithm, where you are given with a graph. For the graph, this is the values directly taken from the graph. Okay. Now you need to calculate for each one with the D0, D1, D2, etc. So we have a graph with the D0, D1, D2. Each time when you consider a particular matrix, you will be knowing that which is the intermediate vertices. So this is what it's been given. So here, if you see A to B, there is A to A, the value is 0. A to B, there is no vertex, no edge, so the value is infinity. A to C, there exists an edge, so the value is 3. A to 3D, there doesn't exist an edge, so the value is infinity. Similarly, you have to take it for all the rows. Okay, if there doesn't exist an edge, the value will be infinity, and there is no cycle, so A to A, B to B, C to C, D to D, it's 0. And if you come for the last vertex, in the fourth vertex, fourth D4, fourth vertex access the intermediate vertices, and if you see, you can get to know that these are the lowest cost in this particular method, or in this particular problem. Okay, so first we will see this example. Where it is, how to share it. So here um, we are going to see the Floyd's algorithm with the all pair shortest path. So you will be starting with a graph where you will be seeing from A. If you take, there is no edge from A to B, A to C, A to D also there is no edge. Okay. So for with respect to this, we need to write the steps. So what is the first step? You are going to construct the array D0. D0 will be constructed by using this graph. Okay. So how to construct it? So if you say that if your I is equal to J, then your Wij is going to be nil or 0. Or if your I is not equal to J, what will happen? Okay. So here we are taking the path from, if there exists a path, we will be taking the cost, or else again it will be infinity. So first we need to construct D0. For we have 4 vertices A, B, C, D. So we take all the 4 vertices and we have to see whether I equal to J. What is I equal to J? I equal to J, you just put it as hyphen, or you can put it as 0. Now what is A to B? A to B, is there any edge? No. So what will be the value? Infinity. Okay. Now similarly A to C. A to C, is there exist an edge? Yes. When you there exist an edge, the value we are taking it as 3. A to D, there doesn't exist an edge, so infinity. Next, take it for B. B to A, what is the value? 2. B to B, no. B to C, no edge. B to D, no edge. Next, C. C to A, no. C to B, there exists an edge. So the value is nothing but it is 7. C to D, it is 1. D to A, 6. Nothing. D to C also nothing. Okay. So this is our initial matrix. So now, what is the next step? Next step says that you need to calculate the weight of the matrix K. The weight of the matrix will be based on the formula which says this: minimum of W of ijk minus 1, comma W of ik minus 1 plus kj k minus 1. K minus 1 indicates it is the previous matrix. So here we need to calculate D1. How will you calculate D1? When you calculate D1, we are fixing it for A. It will not change. Okay. So you can take down the values as it is for the first row, first column, because A is the intermediate vertex. So it will not change for the first row, first column. The remaining values will get changed. So now we need to find out AB. Now we need to find out the value of BC. BC, what is the value? It's infinity. So B to A, what is the value? 2. A to C, what is the value? It is 2 plus, you have to see, it is 3. So 2 plus 3, what is the value? 2 plus 3 is nothing but it will be taking which is minimum, whether it is infinity, comma 5. So now the value will be 5. Okay. So now similarly B to D. For B to D, we are taking B to A plus A to D, infinity. Infinity plus something, infinity. Okay. Next, C to B. C to A is already infinity, so it's infinity, 7. Now, if you take a DB, it's infinity. D to C, you will be saying it as 6 plus 3, which is 9. Okay. Now, we will be moving on to the next matrix. The next matrix is D2. So here your second row, second column is going to be fixed. So we will take it as it is. Okay, for A, B, C, D. ABCD, we will be just taking the values as it is. So infinity to 5 infinity. Okay, now C to C, D to D, A, it will be the same. We need to calculate only remaining thing. B is acting as the intermediate vertex. So A to B, it's already infinity, so no need to go for that. So we will be having it as 3 as the minimum value. Okay, we are going for the minimum value. Now A to D. A to B is infinity, so there is no point. For C to A, if you see, it will be C to B. C to B is 7, B to A is 2, 7 plus 2, it is 9. Next 1. Okay. Now, if you see the value of D3, D3, if you can say that your third column and the third row will not change. Okay. C is going to act as the intermediate vertex. So you will be taking the, will be writing it, and we will just copy down the values as it is. BB, CC already it's there, DD. A to B is infinity. So we will be taking it as 7 plus 3, which is 10. A to D, it's 4, 2 plus. Next. Take. Now we'll go for D4. D4, what is the value? We'll be taking it as 4th row, 4th column is not going to change. So we need to copy it as it is. To A, B to B, C to C. So A to B, if you see, it's 16 plus 4, 20, 20 and 10, 10 is minimum. Next 3 and 5. Now you see C to A, it is changed. Why it is changed? Because it is C to D plus D to A. So 6 plus 1, 7. We have changed it. So this is for all the shortest path. So for any vertex, if you take, this is the shortest path for the all pair shortest path by using the Floyd's algorithm. So this is how you need to find out the value. So we will come back to our here you have seen that in the Floyd's algorithm, what we need to do, it is to find the all pair shortest path, and it will be finding the distances. Okay, so the length of the shortest path from each vertex to all other vertices we have to see, and based on that we will be creating a distance matrix from the given graph. The distance matrix is called as D, and it will be done by for the n by n matrices. So the element in Dij, ith row and jth column of the matrix will be indicating you the shortest path. So Floyd's algorithm, if you see, it is applicable for both the directed and undirected graph, but it should be a weighted graph. So we will start with D0. You have seen in the example, we have started with the D0. We have ended till D4. Why? Because there were only 4 vertices. So for all the 4 vertices, we will be taking each time when you take, first when you take D1, when you see, your first row, first column will not be affected at all. So we will be copying as it is. So only few of the numbers are being always we are just calculating it. Okay, so whenever you see the intermediate vertices, we have to see whether exactly there exists a path. Now, in certain cases, there exists a path in the intermediate vertices, we will be having a path. But the thing is, it may be greater than your current value. So in that case, there is no point in going for doing it again and again. So we will be retaining the old value. That's why we always say that whenever you go for the formula, we are saying that it is minimum among the two, direct as well as indirect. If whichever is minimum, if indirect gives you a minimum value, take it. If direct gives a minimum value, you need to take it. So initially you will be having the weighted matrix. So the weighted matrix will be, if you see, it will be giving you the solution. So there are two subsets. The two subsets are based on whether it depends upon the previous matrix and whether it gives you a direct length or a indirect length. So based on that, we will be calculating the value. So this algorithm is very, very useful for the Floyd's algorithms. So if you see the applications of Floyd's algorithm, the Floyd's algorithm can be used in various real-time applications. If you want to find out the cost for any networking applications, where you will be seeing the time limit, or if you see a traffic system where you want to calculate the shortest path, if you have various routes are being given, how efficiently you can determine the path. That's what we have to see for the shortest path. So every time when you encounter a problem, you just see to that the in any real-time applications, how good you can use the Floyd's algorithm. So if at all there is any networking applications or a traffic applications, or need to find out the path, there will be various paths. From that path you will be choosing the best one. The best one always, it is yielded based on the logic which is given for the dynamic programming. So wherever you have any problems of such types, you can use the Floyd's algorithm. It is very effective also, and the time taken is like considerably, it will be increasing as the input size is increasing. So you need to know what will be the input size. Based on the input size, we will be just using the Floyd's algorithm. Okay, so when you go for the dynamic programming, we have to, both are almost the same, the Floyd's and the Warshall. Now in Warshall, it is used for creating the transitive closure from the adjacency matrix, where it will be a Boolean matrix, and it will be used for a directed matrix, and it need not be a weighted graph. Okay, we will be traversing it by using the DFS or BFS. Each step, if you see, we will be generating the matrices for each vertex. We will be seeing it, and we will be seeing how effectively you can generate it by considering all the various steps. So it's something similar to a recurrence relation, where it will be based on a Boolean operation, and based on the Boolean operation, we will get to know whether there is a direct path. You take as it is. If there doesn't exist a direct path, then only we are going to calculate the value by using the OR and AND operations. Okay, so this is for the Warshall's algorithm. You know, if at all in the previous matrix, if the value is 1, then you will be writing it as it as 1. But here in this case, it is 0. So in that case, you need to find out what is the value of Ik as well as Kj. Ik as well as Kj both should be equal to 1, to get the value of Ij as 1. That always you need to keep it in mind. So the algorithm used for both also, it is almost the similar with the 3 different loops, because we have, for each one we have a set of rows, columns. So we are going with n different stage. If there are 4 vertices, we will be covering 4 stages. So we will be having 3 different loops, where we will be having the Boolean formula, and the time taken will be calculated based on the upper bound lower bound formula, where you will be getting, based on the upper bound lower bound formula, you will be saying that it is n into n into n, which is equal to n cube. So that's how you find out the Warshall algorithm. The same method is applicable for your Floyd's algorithm also. Only thing is, in the Floyd's algorithm, you will be having a weighted graph. And you have to keep in mind that here if you see A to A, it can be a cycle, A to A, B to B, or everything we are getting it as the values are getting changed. But whereas here in Floyd's algorithm, you will not be getting a cycle. You will not check whether you have a cycle or not. So, and also you will not try with any graph with which has a negative value. If at all there is a negative value, then it reflects that cannot go for the distance matrix. So we will be avoiding the negative length always, because whenever you go for a minimum value, only the least value will be always only the negative value. So we try avoiding the negative length, and because here we can we will not be taking the cycles, we will not consider the cycles, but it is applicable for both the directed and indirect graph with a weighted graph. Okay, so here it will be completing all the stages. If you see, it will be completing all the stages, where each stage, if you see, it will be going through a set of intermediate vertices. And always whenever you go for an intermediate vertex, you see to that you are getting the solution of it. Okay, so try take some two problems, try out this and work out and find out how to get the transitive closure if you are given with a graph. Here also you need not, it is this formula, you should know this formula. The initial matrix is your weight matrix as it is, but each stage you will be using this formula to find out what is the next value. So here also you have the same method of writing the algorithm, where you have the have to calculate the value and call the minimum function, which will be returning at the minimum value. So you can see here that all A to A, B to B, C to C, D to D 0. If there exists an edge, then you take the value. For example, A to C, the value is 3. But A to B, that doesn't exist an edge, so you will be considering it as infinity. So once if you complete this, we'll be moving on to the next knapsack problem. So before going into knapsack problem, I would request you to take any two exercises. Take your textbook. Your textbook is Levitin. You have the Levitin textbook, or you can Sani textbook, Fundamentals of Algorithms by Horowitz and Sani. That book also you can verify it. You just take few examples from it and work out for the both the problems, that is Warshall as well as Floyd's, and see whether you are able to proceed it and get the solution. If at all, if you find any problems in between, like I mean, if you are stuck up in some places, please get back to me, so we'll try to solve it together. Okay, so I want all of you to go through these two problems. And from the problem, you will get to know. So here we have seen in dynamic programming how to compute a binomial coefficient, how to calculate the Floyd's and Warshall's algorithm, Warshall algorithm for the transitive closure, and Floyd's for the alpha shortest path. So by this in dynamic programming, there is one more, that is the knapsack problem, that we will see it in the next class.